Hello everyone, welcome back. In this week's lesson, we're going to build a kind of ambient music generator, a little bit similar to what we did last week, except today we're going to play around with the idea of chords and building melodies that are going to be fitting within certain chords. And while doing so, we're also going to talk about some new techniques and ideas to create some generative music. So let's get right into it. So I've already started here and created, I've remixed our blank P5 sketch, and I've put in some boilerplate code that I'm going to go over quickly. So we have our ready variable set to false, and remember we use this variable on the mouse pressed so that we can wait until the user interacts with our sketch to start the sound. Right? We've put all the audio initialization code inside this initialize audio function, which is over here. And currently all I'm doing is just turning down the master volume a little bit so you can hear me while I'm talking and if the sound is running in the background. All right. So the first thing we're going to do is we're going to create a scale. We've done this last week, so we're going to create all the notes of a scale by using tonal.js. And we're going to put these notes in an array called scale notes. So we're going to say tonal.scale.get. And just to begin with here, we're going to just start with a C major scale. Very straightforward. And we're going to use .notes at the end here. That gives us the actual array of notes from that scale. And those notes are now inside our array called scale notes. And in the beginning of this lesson, we're going to use the console a little bit to print out some things. So I'm going to rearrange my window here and bring the console up. This is something you should be using while you're programming, so if you aren't already, make sure you do. Just remember in Chrome.js, if you want to bring the console up and see the actual results from your sketch, you have to select here from the different elements the one that has glitch.me in the name. So here, this is the name of my sketch, tonepoly.glitch.me. And by doing so, now we're using the console for this canvas element here. Which means we can look at our objects, right, and we can print them out. For example, this is the scale notes that we just generated. I'm going to make this a little bit bigger. Okay. So last week we made a bunch of synth objects that could play notes from a scale. Today we're going to mix it up a little bit. We're going to create something called a polysynth, which allows us to play multiple notes at once. And in Tone.js, the way this works is the polysynth is basically a wrapper object around just the regular monosynth, which can only play one note at a time. And all it does is it basically internally creates a bunch of individual monosynths that will be able to play different notes, layer different notes together to form some chords. So let's do an example here. We're going to create a variable called poly, and in initialize audio, we're going to say poly equals new tone dot. And instead of synth, we're going to put polysynth. Now, the parameter here to polysynth is going to be which kind of monosynth we want to be using to generate the sounds. So that could just be simply, for example, a tone.synth object. Right? Then we're going to connect this polysynth to the destination. Remember, that's connected to tone.master, so we can actually hear the sound. And yeah, after we've done this, let's try it out. So in mouse pressed, we are going to play a chord. So my synth is called poly. We're going to trigger the attack release together. Now the difference with a polysynth is instead of giving it just one note, we're going to give it an array of notes. So we are going to say scale notes. Actually, let's just start with a simple array here. We're going to say play a C4, play a E4, and play a G4. And then we'll dive into our scale here in a second. And the other parameter here is going to be the note duration. So let's have it play for a full measure, because this is going to be a chord. We want it to go for a little bit longer. And now we can hear the chord being played when I press the mouse. So there's some parameters we can change here when we first create the polysynth. So after we pass in the synth here object, so this is the kind of synth we want to use. And if you'll remember in Tone.js, there's a bunch of different types of synth objects. Let's go and look at them real quick. Let's open the API documentation. There's different types of synths here. We can see them over there. So we've been using this basic synth a lot, which just wraps around a simple waveform like a sine wave or a square wave. This is the polysynth that you can use to do that we're using today. And then today we'll play around with some of the different ones here. We're going to use a AM synth. AM stands for amplitude modulated synth, and it just has a different timbre and a different kind of flavor to it. So let's try putting in an AM synth instead as the engine for our polysynth. So we get a bit of a different sound here. The other thing we can do with this polysynth is we can pass it some parameters to initialize the AM synth objects that it will create internally. So for example, we're going to create an object here that's going to contain the parameters. I'm going to go and tweak the envelope. That's going to be another object, and the envelope has something called the attack. This is how quickly the sound will rise when we hit a key. I'm going to set it to 1. So now you can hear it coming in a little bit slower. For example, if I put in an attack of 3, here's the difference. Right, so it's changing the rate at which the notes come on. And then there's also something called a release, which is changing how quickly the notes will decay when the chord is over. So for the release, we're going to put 2 there. So this is just an example how we can set some of the initial values of a synth when we create the polysynth. So this just changes the sound a little bit. Okay, so this is not necessary, but just to show you how it works. So now let's connect this polysynth to our scale. So right now you might be wondering, what is this chord we're playing, right? C4, E4, G4. Well, let's bring up our keyboard here for a second. So remember, this is the major scale we're playing with. It starts on a C, right? And then it ends on a C an octave higher, and the major scale is really easy because it's all the white notes. So, all right. Now, if we want to generate chords from a scale, right? A scale, that's called harmonizing the scale. It's a fancy word for just saying we're going to turn this scale into some chords, and we're going to have as many chords as we have notes in the scale. So we have 7 notes in our major scale, so therefore we're going to end up with 7 chords once we've harmonized it. And the formula for creating these harmonized chords is very simple. We're going to start with a note in the scale, and then we're going to jump over one note. We're going to go to the next note. That's the second note in our chord, and we're going to do this again. That's the third note in our chord, and if we want, we can even go one further. We can go to 4th note, and that's what they sound like together. So that's a C major. And if we add the 4th note, that becomes a C major 7. We don't have to go too deep into the theory here. The idea is just how do we create the chords? Well, we start with one note in the scale, and then we just jump in steps of 2 across the scale to get the other notes for that chord. If we want to move on to the next chord, we do the same thing. Start with the D, go up one note, go up one note, and then another. Now it's a D minor 7. Sorry, I don't have an actual keyboard to play with, so I'm just doing this on my computer keyboard. It's a little bit tricky. So we can do this for every note in the scale, and we can generate all 7 chords of the C major scale. So let's do that here in our sketch. So we're going to create a global array here. We're going to call it chords. So just a place where we can store our chords. And in setup, we're going to generate all the chords in our scale, which is basically harmonizing the scale. So first we're going to start with a for loop. We're going to count from 0 to as many notes as we have in our scale. So we can go through all the notes one at a time. And then at each step of the way, we are going to build a chord. So we're going to create a variable, I'm going to call it chord, just an empty array. And then we're going to define what the 3 notes of each chord are. Now, this would be a good time here to bring in a function we did last week, where we were able to grab MIDI notes from an array and wrap around the array depending on the number we put in. So I'm going to just copy these two functions here from a different sketch, bring them into our code. And if you don't remember what these do, you can watch last week's tutorials. But the idea is that we're representing notes by a number, and then we're giving an array of notes to choose from here. And this function allows us to go beyond the available notes and increases the pitch, or below the available notes and also decreasing the pitch. So for instance, going back to our keyboard here, if the notes we have to choose from are the 7 notes of the major scale, our note 0 is a C4, right? Our note 1 is the D4. Our note -1 is a B3. And our note 7, for example, would be a whole octave higher at C5. And this goes kind of in both directions. So a -7, right, would be an octave lower. So this is helpful because we can define just an array of 7 notes, but then we can go higher or lower within that array as we need to. So our chord is going to be made up of 4 notes. So we'll say chord bracket 0, that's our first note. I'm going to say get MIDI note 0 from the array scale notes. Not 0, sorry, index I, because we want to start with the note that we are counting with. Then we're going to generate the other 3 notes in the chord. So the next note in the chord is going to be at index 1, and that's going to be MIDI note I plus 2. So we just jump over 1 note, so we go plus 2, and we're getting our notes from the scale. And we're going to do this 2 more times. So here is going to be plus 4 because we're skipping over more notes, and here is going to be plus 6. And that should be MIDI note. So don't worry about the errors that are popping up here on the right. That's because as I run my code here, this glitch is always running the code automatically. And then once we're done with the chord, we could log it to the console just so we see what we've created. So we can see here, it starts over there. So we can see the 7 chords we generated, right? Starting from each note in the scale, and then we just jump over in steps of 2 to get the other notes in the chord. So now that we have a chord, let's save it. We're going to say chords.push chord. We're going to add it to our list of 7 chords from our scale up here. What's the problem here? Oh, let's format the file. And let's try it out here. So instead of playing this array, we're going to say play the first chord we generated. Oh, it doesn't want to do chords.push here because I didn't define it as an array. So let's do that. Chords.push should be an array. There we go. So let's play the first chord. We can play the second chord, third chord, and so forth. So we have 7 of those. And then we go back to the beginning. Okay. So these are all the 7 chords from our major scale. Now what we're going to do next is we're going to set up some code that's going to automatically switch from one chord to the other, and then get this polysynth to play the chord in the background, just to give us some musical context. And then in the second part of this lesson, we're going to add some melodies, random melodies on top of it that are going to be using the notes of the chord that's being played in the background so that everything always sounds good together. All right. So let's go in and set up some code here that's going to trigger our polysynth on a regular basis. Now we've done this in previous examples. We've used an object called a loop that we could trigger code at a fixed interval We've also used a sequence and a pattern that allows us to play through predefined sequences of notes. In today's example, we're going to mix it up a little bit, and we're going to randomize the amount of time each chord gets to play, just to make our song a little bit less predictable. And the way we're going to do this is we're going to use a function of the transport called schedule. So schedule allows us to say, schedule a particular callback function and give it a time interval that this function is going to run at. And this is a one-time deal. So let's do a schedule here. We're going to create, instead of defining an anonymous function, actually these are too long. Let's use these ones. Instead of defining an anonymous function, we're going to define a named function just so that this is a little bit clearer. So we're going to call this function change chord, and the parameter to it will be the time. Just like all the functions in the transport, there's always a time parameter so that we can get things to play in time within Tone.js. So we're going to schedule change chord, and we are going to schedule it in one measure. All right, and then we're going to start the transport. Actually, they'll just schedule it to start 1 second from the beginning. And then in change chord, just for now, we're going to say poly.trigger attack release. And we'll just play the first chord for now, just to make sure that it works. And this is going to last for 1 measure. Oh, chords needs an S here. Okay. So there's been a little 1 second delay, and then our chord here has played for 1 measure. 1M, remember, stands for 1 measure. We have different units of time. We can also define things in terms of notes and so forth. So M is a full bar or a full measure. So what we can do now is a nice little trick. We're going to make this change chord function basically recursive. So we're going to have change chord schedule the next change chord function using the same line here. Except instead of putting a 1 in the scheduled time, we're going to say plus 1m, which is going to mean 1 measure from now, from this time. This is what the plus does. So if we put just 1m here, this would be an absolute value in the transport, which only would apply in the beginning. By putting the plus, we're saying schedule this 1 measure in the future. So now we can see this is repeating. Every time this change chord is being called, it's going to schedule itself, right? It's going to say, schedule me for 1 measure from now. So what we can do now instead is we can randomize this number here so that we have different durations every time the chord changes. So we're going to say, let's call this duration. This is going to be a random number. So we're going to use floor to round it down, and we'll say random. Let's say we're going to go between 1 and 4 measures. Okay. And then we're going to add the m at the end. So that becomes either 1m or 2m or 4m. So this is going to be our duration for the chord. And then here, we're going to say, play this, change the chord, right? We're not changing the chord yet, but we're going to get there in 1 second. Call this function based on duration in the future. So what we're getting now is varying duration of our chord. It's still always the same chord, but we're going to fix that in a second. And that varies between 1 to 4 measures. Okay. So if we want to get a different chord every time, well, all we have to do is change the index of the chord we're playing. So let's create some variables to help us do this. So we're going to create a variable called current chord. That's going to be the current chord we're currently playing, and we're going to use that mainly in the next example to build a melody on top of it. And then we're going to create a variable called next chord. And to begin with, both of these will be equal to 0. The reason I'm going to use 2 variables is because I want to make sure that I always start on the first chord of my scale, just to make the song a little bit more nice to listen to. We're going to start on the first chord of the scale, which is kind of the home chord. And from there, all bets are off. The chords are going to be randomized. So now we're going to start with the current chord, and then once we've played it, we are going to generate an index for the next chord. So we're going to say next chord is going to be equal to floor, and then we're going to randomize based on the number of chords we have. Okay, so chords.length. And then at the beginning of change chord, we're going to say current chord equals next chord. And remember, because I've set both of these to 0 in the beginning, the first chord is always going to be chord 0. And then afterwards, whatever gets calculated here will become the next chord. Okay. So now we're getting a random chord progression. The program is going to randomize between 1 to 4 measures, and then each time is going to pick a different chord from the scale to play, and it's going to do this forever. Now I've noticed here while this was playing, I'm getting a little warning here from the editor saying we define time and we're never using it, and that's a really good point. So we have to be careful here. When we trigger the synth, we give it a no duration, but if we also want to make sure these are really tightly in time, we have to pass in the time argument. And that's because the scheduler will run these functions. You know, there could be some variations in when they actually get called. So what the scheduler does is it says, here's the time offset for you to schedule the note so that it will happen perfectly in time with the other notes that are following the beat. If you end up having lots of different scheduled functions kind of running at the same time. So important little detail here, but whenever we create these time-based events in Tone.js, whether it's the schedule, loop patterns, sequences, we always get a time parameter, and we have to always pass that time into the notes that we're playing to make sure they actually play on time and not just when that function gets called back. So it's going to sound the same right now, but this will make sure that our whole composition stays in time down the road. So before we move on to the next example, we're going to do one more thing here, which is to add a little visualization to our code so we can actually have something to look at while the sound is playing. And to do this, we're going to use a new object called an FFT. So FFT stands for Fast Fourier Transform. This is an object that's going to allow us to do some frequency analysis on the sound that's being played, and be able to visually represent how much of different frequencies are being heard. So it's similar to the waveform object we've used in previous examples, except the waveform just visualizes the amplitude, the volume of a wave. The FFT is a lot more detailed. It's just looking at a frequency distribution. So it's not going to show us the outline of the wave, just how much of different frequencies are present in the sound. So to create the FFT, we're going to go and initialize audio, and we're going to say new tone.fft, and we're going to pass it a parameter here. I'm going to say 1024. This is the number of frequency bins that is going to divide the spectrum right in. So there's the entire spectrum of frequencies for the sound. This is kind of the resolution, how much detail we want to get. And that has to be a power of 2 always. Just a little aside. We'll put a comment so we remember. So at 1024 will give us 1024 different frequencies, starting from 0 all the way up to the maximum frequency. I forget what that is. And then we're going to say connect. We're going to connect tone.master to our FFT. And the reason we're going to do this actually would do this the other way around, sorry. I'm going to say tone.master connect FFT. So that's going to send the audio from our master node, our master block in our audio chain, which is the final one everything gets connected into. That's going to go into our FFT and give it something to work with so that it can process the sound and then give us the data to visualize. Now, once we have our FFT object in draw here, we're going to visualize the FFT. So we're going to create a for loop here. Well, first let's get the, just like with the waveform, the actual values for the FFT are going to be in an array. We're going to call it buffer, and we'll say get value 0. And then we're going to create a for loop that's going to iterate and draw all 1024 of these values we got from the buffer. So count from 0 to buffer.length. And then inside the for loop, we just need some kind of way of representing these values. Now, just for fun here, we're going to draw them along a circle. So we're going to create this circular pattern here. And so that means we're going to have to calculate an angle, based on the loop counter. So we're going to map I, which we know goes from 0 to buffer.length. We're going to map it to an angle from 0 to 2 pi, or 0 to 360 degrees. And then once we have this, we're going to rotate by the angle. And then we're going to draw, we can draw a line. We're going to draw just a point here. And we need to figure out how, well, first of all, let's get the value from the buffer. So this value is going to be in decibels, okay? And it's going to range from about minus 100 to 0. So if we were to draw a point here at, let's say, 0 and dB, if we use it as a y value, let's see what happens. And nothing happens because we need to set a white stroke in order to see our lines. Okay. So we can see our FFT being visualized here. Now we're drawing around the 0, 0 point, so let's do a little transformation. We're going to translate our origin, bring it to the center. So here we start from 0, and then we go around the circle, drawing all the different frequency bins that make up this sound. So depending on the notes we're hearing, this pattern is going to look a little bit different. So let's make this, just do one final little tweak here. So you notice if I resize my window, this doesn't change in size. So we're going to make this visualization a little bit more dynamic. Okay? So first we're going to take our measuring tape out, and we're going to figure out which of these dimensions is the smallest. Is it the width of the window or the height? And that's going to become our radius for that circle. So we'll use the min function. So min takes two numbers, right? It's going to take the smallest of the two, and then we're going to divide that by 2. So it's going to say, look at width and height and pick the smallest one. So depending on the size of the window, right? So here the smallest dimension will be width. So we're going to use half of that as the radius to make sure our visualization always fits in the screen. So that becomes our radius. And here, let's create a y variable. So now we know that we have this value here in the buffer. It goes from minus 100 to 100. I know this from reading the documentation. We're going to map this number to a number between 0 and radius. And then we're going to use that instead as our coordinate for the point. And notice here I choose to use y. It just means that my point will be drawn like vertically. I could have chosen to use x and it would be drawn horizontally. It's just going to change where things start around the circle in the visualization. Now if I resize the window, you can see that this is actually resizing itself to fit, which is nice. This is all because of this min function here. And then just let's make it a little prettier by adding some fade to the background. That looks cool. All right, so we've created a bunch of chords from a scale. In this case, the C major scale, but we could use, any scale. We could use minor, right? We're going to get a different tonality. And we saw in previous weeks, we have lots of different scales we can use. For example, different modes. One of them is called Phrygian. It sounds a lot like minor, probably because the first chord is minor. We're going to go to, let's say, an E Phrygian. Right? So we just get different flavors. Then from that scale, we generated all the 7 chords from the scale, put them into this chord array, and the chord generation is really simple. We just start with each note on the scale, and then from there we jump in steps of 2 to get the other notes in the chord. That gives us a full 7th chord, that's what they're called, so they're made out of 4 notes, and we'll have this will give us lots of notes to choose from when we create our melodies as well. We've used the Polysynth to create an object that can play multiple notes at once, allowing us to create a chord. And here I'm using an AM synth as the synthesis engine, just for fun. And then over time, our chord is changing, and then it's generating not only a random chord in the scale to play next, but also a random amount of time to play the current chord, defined in number of measures. So we're going to leave it at that for this lesson. In the next tutorial, we're going to talk about adding layers of melody on top of this. So I'll see you there.